For 11.4, we get into spheres. As most people believe, we live on a sphere. So there's one application, but there's plenty of others for what we're about to do today. So today, guys, we're going to talk about the surface area of a sphere. We're going to talk about the volume of a sphere and how to calculate those. We're also going to talk about these things called great circles, which is kind of a new term and a term that I don't really use very much, but a great circle, I'll cover that as well, and how to use a great circle information to find volumes of spheres or hemispheres, anything related to spheres. So here we go, guys. The surface area of spheres. There is a way to derive this formula that I'm just gonna give you right now, but we're not gonna do it for the sake of this class. But the surface area of a sphere, capital S, is equal to 4 pi r squared. Okay, so essentially, what you can gather from this, since we know that pi r squared is equal to the area of a circle, the area of a sphere is essentially just 4 of those circles pitched together in order to create a sphere. Again, it's kind of hard to derive this with you guys right now. You can think about this though, like the textbook has a little bit of a hint when, like if you were to create like a tennis ball out of material and you cut that thing apart, what you'd come up with. But anyway, you guys can explore that on your own if you'd like. So pi r squared times 4 is how we find the surface area of a sphere, okay, the sphere. So they give you a couple of these where you just, are plugging in numbers for the radius there. So you have, for the first one, 4 times pi times 7.1 squared. Okay, and for the other one, you would have 4 times pi times, be careful, this is a diameter and we need a radius, so this would be times 11 squared. Okay, so you can do those out on your calculators. And when you do, you should be getting, let's just do it out here. I haven't done this ahead of time. This turns into 50.41 times pi times 4. So times 4 times pi gives me 633.5-ish millimeters cubed. And when I do my other one here, 11 squared is 121 times 4. 121 times 4 is 484, so 484 pi, which gives me 1,520.5 feet, in this case, cubed. Okay, so now let's get into the great circle. So the great circle, you guys, all this is saying is that if we were to take a plane and cut it through a sphere, okay, so this is a 3D sphere, imagine. Here's the center. If we took a plane and cut it through this, like a piece of paper, and we slipped it through the sphere, if it goes through as a diameter, okay, so it goes exactly through center like this, then if you can imagine looking down on that, okay, so if this was a side view, looking down on that slice right there, it would be a perfect circle because it went right through the diameter at the center. Okay, so they call these great circles. So a great circle essentially just cuts a sphere exactly in half. It's the circle so like you can imagine if you were looking down on this from an angle, this would be like, I don't know, I'm terrible at drawing these things, but you would essentially have a half circle and the top of your shape there would be like a circle, right? If that's hard for you to visualize, there are some more pictures in your textbook that kind of lay this out. Okay, so anyway, what you have to know is if you were to find the area of a great circle, that's the area of a circle that splits exactly a sphere in half. Okay, so let's go down to example 2a and see if we can clear that up a little bit. It says find the surface area of each figure. So they want us to find the surface area of a sphere. So we know that formula. That's 4 pi r squared. Okay, if the circumference of the great circle, okay, so the distance around the circle at the very center of that circle, sphere, is 16.2 pi feet. Okay, so we know that circumference is equal to 2 pi r. Okay, and in this case, we have 16.2 as our circumference, pi is equal to 2 pi r. So if I want to know what r is, I could divide both sides by 2 pi. Okay, and when I do that, the pi's cancel out, the 16.2 and the 2 cancel out, so I know that my radius, like they simplify, that my radius is equal to 8.1 on my sphere. Okay, so I can now take this and plug it into my sphere equation there, formula there. So 4 times pi times 8.1 squared is equal to, let me just do that out real quick. So we have 8.1 squared, okay, times pi times 4. And I get 824.5 approximately feet squared. So 825.5 feet. Sorry, not squared, to be cubed, because we're doing volume. Oh, sorry, no, we're not doing volume. What are we doing? We're doing surface area. Sorry, guys. Okay, so hemispheres. Hemispheres are like these half spheres, right? So you could think of it like, you know, side view would look something like this, like a bowl. Okay. If the area of the great circle is 94 millimeters squared. So we're talking about surface area, you guys. So imagine if you cut a sphere in half, you would have the area of like the bowl shape around the side. But then you can also think about this like a drum too. There's also, we also have to consider the area of the surface that's the great circle that is on top of that. Okay, so you can think of it like a covered bowl, if you will. So we need to know the surface area of the lid and the whole bowl, right? So the lid is given to us. It says the area of the great circle, or the lid of that bowl, right? The great circle is the circle that's just right in the middle of the sphere. If that area is 94, they gave us that. They want to know what half of the, essentially what hemisphere, hemisphere means half, right? Half of the sphere. What is the area of the other, of the whole hemisphere, including that top? Okay, so that's what we're trying to find. So in order to do that, I need to figure out what r is. Okay, so I can do that because the r value is going to be the exact same as the r value in the great circle. So what I'm going to do is I'm going to set that 94, the area of the great circle, to equal pi r squared, because that great circle is just a circle. It's not a sphere, so it's just pi r squared, right? So then I'm going to solve that for r. So I'm going to divide both sides by pi, so we get r squared is equal to 94 over pi. Therefore, the radius is equal to the square root of 94 divided by pi. Okay, so if you hop on a calculator and you take 94 and you divide that by pi, and then take the square root of that, you should be getting, and I'm doing it here with you, take the square root of that, I get the radius is equal to 5.47-ish. Okay, so now I'm going to plug it into the sphere formula, but then I got to cut it in half, right? So here we go. We have 4 times pi times 5.47 squared over 2 will equal my semicircle, or my semisphere, my hemisphere. And so when I do this, I can cross cancel here a little bit. So I'm going to do 2 pi times 5.47 squared. So I kept everything in my calculator, times 2 times pi, and I end up getting 188 millimeters. Okay, and remember what I just calculated. I calculated, like if I had a sphere, I cut it in half, right? So I calculated the surface area of the bottom half, or a bowl type shape. But then if I want the total surface area, I got to also include the lid to the bowl. So I'm going to add 94. So plus 94 is equal to 282 millimeters squared. Okay, and finally they want a hemisphere if the circumference of the great circle is 3,000, is that right? 3,000, and I don't believe this is right. I believe that's the answer that I gave you guys there, so I apologize. Let's just work it anyway for fun. Let's imagine that I put it in there right. So 36 pi, and maybe I'll fix that on your homework sheets before you see this. But anyway, centimeters. Okay, so for this case, okay, if the circumference, the distance around is 36 pi, how do I find r? Well, we know circumference is equal to 2 pi r, right? So if my circumference is 36 pi, I can substitute that in. So 36 pi is equal to 2 pi r. So I'm going to divide both sides by 2 pi. And when I do that, I figure out that my r value here, this cancels, is equal to this cancels, and that turns into an 18. Okay, so the radius is 18 on my sphere. They want to know the hemisphere again. Okay, so let's figure that out. So for the hemisphere, I'm going to go ahead and plug in 18 for my sphere. So 4 times pi times 18 squared. Okay, and then I'm going to divide that by 2. So it turns into 2 pi times 18 squared. So when I do that, I get, let's try it out, 18 squared times pi times 2. I get 2,035.75 centimeters. And what I just found was the surface area of the side of the bowl, but now I need the top, right? So I need pi r squared on top of that. So I'm going to add pi times 18 squared. Okay, so if I take 18 and square it, I get 324, and then I multiply that by pi, I get 1,000, so this is equivalent to 1,017.88-ish. Okay, I'm going to add that to my bowl now, 2035.75, and I get the answer that was here, 3,053, write this up here, 3,053.6 centimeters squared. Okay, sorry about that one, but that's how you would do that one for 2C. Let's keep cruising on. So the volume of a sphere is given by the formula V equals 4/3 pi r cubed. Again, we could derive that. And there's a little example in the book of how that's derived. I'm not going to go into it too much here. For now, I'm just going to give you the formula and ask you to apply it. So example 3 says, find the volume of a sphere whose diameter is 7.4 inches. So diameter here, we need to figure out what the radius is, right? So I'm going to take 7.4, divide that by 2, I get 3.7. So r is equal to 3.7. Okay, now that I have all my pieces, I can plug it in. Volume is equal to 4/3 pi times 3.7 cubed now. We're in cubes now. So take 3.7, multiply it by itself 3 times, or cube it, and you should get 50.653. Multiply that by pi, you should get 159.1. Then multiply that by 4/3. An easy way to do that is just take your answer, multiply it by 4, and then divide everything by 3. And you should be getting 212.2. And then in this case, we're in inches cubed. And for our final bit here, 3b, it says find the volume of a hemisphere. Okay, so half of a sphere, when the area of the great circle is 249 millimeters squared. Okay, so we know that area is pi r squared. And in this case, we know that the area is 249. Okay, so if we want to know what r is, we can solve this. So r squared is equal to 249 over pi. Therefore, r is equal to the square root of 249 over pi. So then you take 249, divide by pi in your calculator, then take the square root of that, and you should get a radius of 8.2. 0.902 something, something, something. I'm just going to keep that in my calculator. Okay, so I'm going to take this now and I'm going to plug it in. So volume is equal to 4/3 pi times the radius cubed. So I have that number in my calculator. I'm going to cube it. I get 705.6. Then I'm going to multiply that by pi. I get 2,216.8-ish. Then I'm going to multiply that by 4. I get 6,964.2. Divide that whole thing by 3. And then the volume of the total circle would be 2,321.4. But notice they're only looking for a hemisphere. So I'm going to divide that by 2. Okay, and when I divide that by 2, I get 1,160. Oops, I don't know what's going on. 1,160.7 millimeters cubed. And I'm noticing that's not the same answer as what's in the book. So let me just make sure here. Okay, the volume of a hemisphere in the area of the great circle is 249 millimeters squared. Let's just make sure that we did this whole thing right, guys. I'm going to back out just a little bit. Sorry for this on the video, but I'm going to have to do it. So 249 divided by pi. 249 divided by pi is equal, maybe you already figured out my error here, 79.2. Take the square root of that. I get 8.9. So this is find the volume of the hemisphere in the area is this. Okay, so I'm going to take that 8.9 and plug it in. So I'm going to cube it. Multiply by pi. Multiply by 4. Divide by 3. Oh, there is a mistake. So when I did that calculation again, I got 2,955.7. And then divide that by 2. And now we get the right answer. So I apologize, guys. 1,477.9 millimeters cubed. Not sure what went wrong with my calculation, but and be curious to see if anyone else ran into a calculation error. But anyway, we'll talk about that next time. That is all for this section. You guys have a good rest of the day. 11.4 homework due next time.